In the last section, we looked at exponential functions, and now we're going to look at the inverse, which is a logarithmic function. In this presentation, we're going to look at the graphs, so this is not going to be anything new. Okay, so let's talk about exponential functions and logarithmic functions at the same time. So our exponential function, remember our basic equation was f of x equals b raised to the x. We have the restrictions on b. B must be greater than 0, and b cannot equal 1. Our notation for a logarithmic function is log base b of x, where b is also greater than 0 and cannot equal 1. So notice that we have the same restrictions on our logarithm as we had on our exponential. For exponential, we had our domain was all real numbers, or negative infinity to infinity. Remember that the logarithm is the inverse function, so my domain becomes my range. My range is going to be all real numbers, or negative infinity to infinity. My range for my exponential becomes my domain for the logarithm. So we're going to replace my y with an x. We get our domain is x is greater than 0 or 0 to infinity. My y-intercept for an exponential function was always 0, 1. My y-intercept is now going to become an x-intercept, and we want to flip our coordinate around, so it's going to be 1, 0. We had no x-intercepts for a exponential function. We will have no y-intercepts for a logarithmic function. For an exponential function, remember we also talked about the asymptote. We had a horizontal asymptote at the x-axis, or y equals 0. For a logarithmic function, we switch it and we will have a vertical asymptote at x equals 0. Now, if you recall, we had two different types of exponential graphs. We had if b is greater than 1, then it is an increasing curve. And it looks something like this. Similarly, for a logarithm, if b is greater than 1, we will have an increasing curve. And it will look something like this. For an exponential function, if b is between 0 and 1, we have a decreasing curve. Similarly, if b is between 0 and 1 for our logarithm, we will also have a decreasing curve. So those are going to be the things that we want to keep in mind when we talk about exponential and logarithmic functions. So let's go ahead and look at some examples now. So for example A, we have f of x equals 3 to the x. We also want to graph the logarithm along with it. So just like we did in the last section, we're going to do the same thing. I'm going to start by finding points on f of x. I'm going to use my standard numbers for x. I'm going to use -1, 0, 1. 3 to the -1. The reciprocal of 3 is 1/3. 3 to the 0. Anything to the 0 is 1. And 3 to the 1 is 3. Now I'm not going to calculate my logarithm. I'm going to use the fact that it is the inverse of 3 to the x, or the exponential. So I'm going to flip my columns. I'm going to let x be 1/3, 1, and 3. And I'm going to let my f inverse be -1, 0, and 1. Alright, so if we go ahead and graph this, we get -1, 1/3, that's 1 to the left, 1/3 up, 0, 1, and 1, 3. So if we go ahead and graph this, it will look like this. This is f of x. Now for my f inverse, I'm going to use green to graph that. We get 1/3, -1, so we're going to go 1/3 to the right, 1 down, 1, 0, and 3, 1. And that's not a very good graph because I did touch my x-axis, but I'm going to leave it alone because I don't know if I can do any better. Last thing we want is we want to go ahead and graph the line y equals x so that we can see the symmetry. All right, let's look at one more. Okay, let's look at f of x equals 1/2 raised to the x. And let's make our table. I'm going to use -1, 0, and 1 again. 1/2 raised to the -1, that's the reciprocal of 1/2, which is 2. 1/2 to the 0 is 1. And 1/2 to the first power is 1/2. Let me go ahead and label that correctly. That's f of x. All right, for our inverse function, we're going to switch our columns. So we get x is 2, 1, and 1/2. And we get f inverse of x is -1, 0, and 1. Okay, if we go ahead and graph this, the first one we get -1, 2, 0, 1, 1, 1/2. We draw our curve. Second one, I'm going to go ahead and use green. So we get 2, -1, 1, 0, and 1/2, 1. We want to draw our line y equals x through the middle, and we have our two graphs here. Okay, so that takes care of graphing logarithmic functions. In the next presentation, we're going to talk about evaluating logarithmic functions. So take a quick break, and I will see you again in a few minutes.